Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P050A, indicates a fault related to the cold start idle air control system in the Honda CRV models ranging from 2011 to 2016. This issue may arise due to several factors affecting the smooth operation of the vehicle's air intake systems during cold starts. The core components involved in this system include the electronic throttle control actuator, mass airflow (MAF) sensor, intake air temperature (IAT) sensor, and the powertrain control module (PCM). The fault could arise from poor connections, blocked air intake pathways, or issues with the throttle body itself. Correctly diagnosing this problem is crucial for ensuring optimal engine performance and fuel efficiency, as it directly affects how the vehicle's engine idles during cold starts. Troubleshooting this DTC is essential to avoid potential long-term damages and maintain the vehicle's reliability. DTC P050A refers to a performance problem within the cold start idle air control system, often connected with various sensors and components like the throttle body and air cleaner. The cold start system is designed to ensure the engine receives an appropriate air-fuel mixture during cold starts, optimizing performance when the engine is not fully warmed up. The electronic throttle control actuator is responsible for regulating airflow based on instructions from the PCM. The PCM evaluates inputs from the MAF sensor and IAT sensor to maintain proper engine operation. If there are blockages or faulty sensors, the engine's idle can be adversely affected, leading to performance issues. These components are typically located within the intake system of the vehicle, making visual checks an essential part of the troubleshooting process. Several underlying issues can cause DTC P050A. The first potential cause is a poor connection or a blockage within the intake air duct, which could restrict airflow necessary for optimal engine performance. If airflow is restricted, it can lead to improper idling, especially when starting cold. The second possible cause is a blockage or poor connection at the air cleaner housing. If the air cleaner housing is compromised, it can impede the necessary clean air from entering the engine. Additionally, the air cleaner element itself can become dirty or clogged with debris, which directly restricts airflow and can lead to performance issues. Therefore, each of these potential causes should be carefully inspected. The symptoms associated with DTC P050A typically manifest as noticeable engine performance issues. One of the most common symptoms is a rough idle when starting the engine from a cold state. This can be particularly disruptive and may lead to a lack of smoothness during initial acceleration. Another symptom is a poor engine response, which can hinder the driver's ability to accelerate confidently, impacting overall driving safety. Furthermore, increased fuel consumption often accompanies this DTC due to inefficient air-fuel mixing when the engine is cold. Observing these symptoms can aid in recognizing that there is an underlying issue needing further diagnostic checks. The first troubleshooting step involves turning the ignition switch to the on position, which activates the vehicle's onboard systems. Utilizing the Honda Diagnostic System, HDS, check for any pending or confirmed DTCs, including the P050A. It's essential to identify whether any other DTCs are recorded, as these may provide additional insights into other potential issues affecting the vehicle's performance. If additional DTCs are detected, they must be addressed first using their specific troubleshooting protocols. If no other DTCs are present, this will lead to the subsequent troubleshooting step for diagnosing P050A specifically. In this step, you will visually inspect the intake air duct, Check for any signs of poor connections or potential blockages that could impede the air intake. Any restrictions in the intake route can lead to incorrect air-fuel ratios during the initial engine start, thereby causing DTC P050A to trigger. Ensure that all connections are secured properly and free of any debris. If everything appears in good condition, proceed to the next step. However, if blockages or connection issues are found, these must be resolved to ensure proper airflow and system functionality. The third troubleshooting step requires a visual inspection of the air cleaner housing. Similar to the previous steps, check for any poor connections or blockages that might restrict airflow. The air cleaner housing is crucial as it houses the air cleaner element that filters the incoming air into the engine. Any obstructions here can lead to increased intake resistance, adversely affecting engine performance. Ensure that the housing is intact and free from debris. If the air cleaner housing is found compromised, it should be replaced to restore normal airflow conditions. In this step, focus on inspecting the air cleaner element for dirt or debris that could inhibit airflow. A dirty air cleaner element can prevent adequate amounts of clean air from reaching the engine, negatively impacting performance. The element must be checked thoroughly for any obstructions. If it is found to be dirty, replacement is necessary. A clean air cleaner element is vital for maintaining optimal engine efficiency and performance, particularly during cold starts. If the element is in good condition, you may proceed to the next troubleshooting step. For step 5, let the engine cool until the value of ECT sensor 1 reads 122 degrees Fahrenheit, 50 degrees Celsius or lower before proceeding, as this is critical for further diagnosis. Once cooled, use the HDS to clear the DTC, resetting the system. Start the engine and let it idle for at least 10 seconds, which allows the system to reevaluate conditions. It's necessary to monitor the onboard diagnostics (OBD) status for DTC P050 during this process. If the HDS indicates a failure, it confirms that the issue persists, and you should proceed to the next step in diagnostic troubleshooting. If it shows a pass, the issue may have been temporary or intermittent. Step 6 entails performing the Electronic Throttle Control System (ETCS) test with the HDS. This test evaluates the functionality of the throttle actuator control valve within the throttle body. A properly functioning throttle actuator is essential for managing air intake based on engine demand. If the test confirms normal operation, you can progress to the next step. However, if the HDS indicates a fault with the throttle actuator control valve, the throttle body will need to be replaced. This component plays a significant role in throttle response and fuel efficiency, so addressing any faults promptly is critical. In step 7, the MAF, mass airflow sensor performance needs to be assessed. Start the engine and maintain an engine speed of 3,000 RPM without load, allowing adequate airflow through the engine. Monitor various parameters with the HDS as the radiator fan activates. While holding the engine speed for 30 seconds, check that the values returned by the MAF sensor fall within the specified range of 7.0 to 8.6 grams per second, G-seconds. If the readings are consistent with these thresholds, the MAF sensor is functioning correctly, and you can proceed to the next step. However, if the values don't match the expected range, then the MAF IAT sensor should be replaced to mitigate any impact on combustion and performance. The 8th troubleshooting step involves testing the IAT, intake air temperature sensor. First, ensure the engine is turned off and let it cool to the ambient temperature. This cooling phase is crucial for accurate temperature readings. Subsequently, turn the ignition to the on position and quickly record the IAT sensor's value using the HDS. Compare this reading against the ambient temperature. A discrepancy of 5.4 degrees Fahrenheit, 3 degrees Celsius, or greater indicates that the sensor is faulty and needs to be replaced. If the sensor functions within acceptable ranges, inspect the throttle body for any signs of carbon deposits or damage. Cleaning or replacing the throttle body may be necessary to ensure optimal performance. The final repair verification is a crucial step to confirm that all issues related to DTC P050A have been effectively resolved. Start by reconnecting all connectors that were previously detached during the troubleshooting process. Next, perform a reset of the Powertrain Control Module, PCM, using the HDS, which is integral in ensuring that the system operates under the latest conditions set after repairs. Follow this by letting the engine idle for about 10 seconds to monitor its performance. Finally, check the OBD status using the HDS to verify whether DTC P050A has returned or whether it indicates a pass. If it indicates a pass, the troubleshooting will be complete, confirming that the cold start idle air control system is now functioning correctly. To maintain optimal performance and prevent future occurrences of DTC P050A, implementing a proactive preventive maintenance routine is essential. Regularly check the air filter and replace it as necessary to ensure that clean air flows into the engine without obstructions. Additionally, consistently inspect the intake system for blockages or leaks that could impede airflow. Keeping the MAF and IAT sensors clean and free of debris will also help maintain the accuracy of readings, critical for the engine's functioning. Establishing a regular maintenance schedule will ensure that the cold start idle air control system operates efficiently and keep any related issues at bay. In conclusion, DTC P050 is an essential code indicating a performance issue within the cold start idle air control system in the Honda CRV models from 2011 to 2016. Effectively diagnosing and troubleshooting this DTC requires systematic approaches, including visual inspections and component tests. Clear step-by-step troubleshooting, as outlined, is fundamental for addressing the specific problem areas related to airflow and sensor functionality. Equally important is establishing a routine preventive maintenance regimen to avoid future complications. By understanding and following these structured processes, vehicle owners can enhance the reliability and efficiency of their Honda CRV vehicles. Please like and subscribe to the channel. See you next time.